Hey everyone, this is Allison, and I wanted to give you a voiceover on this particular type of rate structure, which is water budgets, because I just think it's easier to do the voiceover and explain it to you this way rather than make a bunch of pages, and I think you'll still be confused. Of all the rate structures, this is the one that most people have a problem understanding, and it is more complicated and I always say it's difficult all the way around. And the reason for that is it's individualized and it's based on a formula. It's not like an increasing block or a decreasing block, which is like it's the same for every residence. It's, again, individualized. Not very many places have adopted water budgets. Some districts and some agencies, some cities have adopted modified water budgets. And the reason is because you often can't even get a board or city council to understand it. It's actually not that complicated, but you got to pay attention to it. So it's a little bit difficult to explain to customers, etc. It is an equitable budget system. It's an equitable rate structure. And by that I mean is it doesn't penalize any one group over the other. It is individualized. It is based on lot size and family size, and it's computed with a formula. So let's the next slide. This is a map. It's called a reference evapotranspiration map. You can find it anywhere. It's also in our files section, and it's really quite handy. And if you look at it, you'll see all those different colors, and those different colors correspond to a precipitation zone. And the colors are numbered, right? So, for example, on the far northern coast, you see zone 1, which is kind of a lavender color. Zone 3 is a little bit lighter lavender. Zone 4 is even darker lavender. And those correspond to names. On the right, you'll see a chart up at the top. And so, for example, zone 2 is coastal mixed public area. Zone 3 is coastal valley and plains, north coast mountains, and so on all the way through to zone 18, which is down by San Diego. It's in Imperial County, and that's Imperial Valley, Death Valley, and Palo Verde. Okay, so typically, because we know how California's set up, the more coastal you are, the more precipitation you get. The more inland you are, the farther south you are, the less precipitation you get. And those color-coded zones correspond to that. They're based on historical data, and they're actually pretty accurate. So if you ever need a reference model, this is the one you would use, and it's called the reference evapotranspiration. Now, you will also see a chart on here on the right, and it says monthly average reference evapotranspiration by ECO zone inches per month. And I want you to take a look at zone 1, January. It says 0.93. That means the average precipitation amount for zone 1 in January is 0.93 of an inch. Okay, if you look at February, it's 1.4, 2.48 in March, 3.30, all the way across. So every zone has a reference. It's a monthly average precipitation, and that is called the reference evapotranspiration rate for that zone. I live all the way down in Riverside County. I am never too sure if I'm a zone 6 or a zone 9. But if you look across zone 6 and zone 9, there's some pretty big differences in precipitation amounts, right? So where you are, I wish this was a little bit more detailed. And we're going to use this later, but I wanted you to be aware of this map because you can use this wherever you are too, right? If you don't have access to real-time precipitation data, this actually works remarkably. So here is the formula for a water budget. A water budget is comprised of two things, an indoor budget and an outdoor budget. Indoor budget is typically set at 55 gallons per person per day. You know about GPCD, okay? But and how that equivalates. So we typically say it's 55 gallons per person per day. That is now going to be a state standard that is actually going to decrease over the coming years. Right now, it's 55. I think it goes down as low as 47. And while 7 gallons per person per day doesn't sound like a lot, it's actually a fair amount. Is it unmeetable? No, this is certainly a meetable goal with if you have indoor appliances, for example, water saving toilets, maybe a water saving washing machine, you don't take super long showers, you can meet this goal of an indoor budget. Las Vegas actually drove theirs down to about 35 gallons per person per day some time ago. So 55 gallons per person per day is very doable. Where we have the more difficult understanding area is the outdoor budget. And the outdoor budget is set this way. Irrigated area times ET, which is evapotranspiration, times plant factor, which we're going to talk about, all divided by irrigation efficiency. Okay? So these are part of the outdoor budget computation. You take that number and then you add it to the indoor budget, and that gives you a total budget for a month. So let's go to the next one. Rates are of course, rates vary throughout our state. But here's an example of how you might, and I'm going to show you a computation in a minute of the indoor and outdoor. But here's an example of an actual rate structure. So indoor budget, right, is based on 55 gallons per person per day, is 204 per unit, right, which is 748 gallons. The outdoor budget is 226. So if you stay within your indoor and outdoor budget, you're probably going to be okay. Where you really, and I've seen this over and over again, where you really start to have trouble is when you go over that outdoor budget amount. So inefficient use would be, in this example, $3.08 per unit. Excessive use is $6.16, and wasteful use is $11.29. So that's per unit, right? That's a lot of money. So you can see that your child goes outside and plays with the hose and leaves the hose on, and you're in trouble, right? Because you're going to be up in wasteful use pretty quickly. So remember, this is set by your ET rate. Your ET rate changes every month based on the weather, and that also changes based on days in the month, because that's how we set, right? That's how you set rates in this structure. That, in my opinion, makes it very, very difficult for customers to understand a water budget. So I have some examples here. Okay. So remember, this is calculated based on your lot size. So you're not penalized if you have a large lot, but you're, how do they get these lot sizes? Well, the state or your own agency does an aerial flyover, and they photograph everybody's individual home, and they know by that aerial flyover how many trees you've got, how many shrubs you've got, which use less water, how much grass you have, how much concrete you have, and then they use a computer program to calculate how much hardscape you have versus how much shrubs you have versus how much grass you have. What's the footprint of your house? So all of this is calculated by the state to come up with these numbers. So let's look at the indoor budget first. Typically, you'll see here number of occupants, and we have two examples. We have one in September and one in January for a large lot, and then one for a small lot. So usually to get the number of occupants, they don't ask you how many people live in each of your houses. What they do is they use the census data to get an average number of occupants. In most cases, it's usually around 4. Okay? So whether you're in a large lot or a small lot, whether it's January or September, it does not matter. Sorry for the typo in that top column where it says sample 1 September. It's weird. I'm sorry about that. So the number of occupants is always going to be 4, right? You can apply for a variance if you have more people in your household than that. And if you have less people, basically you just let them think that you have 4 because it increases your budget. We know that the actual standard is 55 gallons per person per day. So if you take 4 times 55, that means that each household gets 220 gallons per day for indoor use. Now, as the water flows in through your meter, does it know if it's indoor or outdoor use? No, it has no idea, okay? But this is how your budget is calculated for your total water use. So we're talking 220 gallons per day, whether it's a large lot or a small lot, whether it's September or January, because really personal use does not change depending on the weather, right? You may take one extra shower in the summer, but it's typically like really similar, right? It doesn't change. So you're always going to flush, you're always going to cook, etc. So if you calculate that in September times the days of the month in September, you're going to come up, okay, I actually put it in there. Days in the month of September is 30. So if you take 220 times 30, you're going to come up with 6,600 gallons. Okay. If you do that for January, there's 31 days in the month, you're going to come up with 6,820 gallons. But if you divide that by 748, it's still going to be 9 units. Okay. They almost always round up to about 9 units. So your indoor budget is going to be 9 units, no matter what, for 4 people. That's not a huge amount of water, right? You can't be just leaving your sink running if you've only got 9 units. Here's where we get to a little bit, it's a little bit more complicated. So let's look at the large lot. Let's look at the large lot in January and September. So they have decided, they've done the aerial flyover, and your lot size is 14,000 square feet. That's a pretty big lot, okay? And when they did the aerial flyover, they discovered that there's about 6,000 square feet of hardscape, driveways, your house footprint, maybe a garage. So you have a 14,000 square foot lot, but it's not all irrigable, right? 6,000 square feet of it, you're not irrigating. So you take 14,000 minus 6,000, and you come up with 8,000 square feet of irrigable area on this large lot. Now, we're looking in September. So the evapotranspiration rate, remember that from our beautiful little map? For this month in September, it happens to be 6.42. And in January, it's 2.17. So this is this is the ET rate that changes every month. Then you have a plant factor. Now, we haven't gotten into landscaping yet. A plant factor number is assigned for every single plant. So grass happens to be 0.8 or 0.9. A drought tolerant plant is 0.3. Okay, so it gives you an idea of the breadth of the numbers. In this particular example, I used the number for grass, 0.8. In reality, nobody's going to use 0.8. They're going to use 0.5 or 0.6. They're going to expect that you have some shrubbery, that you have some low water using plants. It's not all grass. So then you have a conversion factor, which is 0.62. That is one number that you really want to commit to memory. That converts inches of water to gallons of water. If you're going to commit any number, any conversion factor to memory, do that one, conversion factor. Now, irrigation efficiency, your agency is going to set that. So drip irrigation when it's brand new is about 80 to 90% efficient. Spray irrigation is rarely over 50%, even when it's brand new. Like even if you're good at it, the mere fact that you're putting water up into the atmosphere and spraying it over something is gonna really dramatically decrease your efficiency. But a lot of people do have drip, which is why I set this at zero point 0.7, okay, 0.70 as irrigation efficiency. So now we're going to calculate this. And I have the calculation in parentheses. I also have it written out in the little starred area. So we're going to take irrigated area, which in this case is 8,000 square feet, times evapotranspiration for that month, which is 6.42, times the plant factor, which I set for grass at 0.8, times the conversion factor, because we're going to change inches of water to gallons, all divided by irrigation efficiency. So if you do that, okay, you're going to go 8,000 times 6.42 times 0.8 times 0.62, all divided all divided by 0.7, and you're going to come up with 36,392 gallons. If you divide that by 748 to get units, you're going to come up with 49 units. So that means in September, this landscape gets 49 units of water for outdoor irrigation. Again, we don't know if it's outdoor or indoor. So we're going to take outdoor irrigation units and add it to monthly indoor units, which is 9. That's our indoor budget. And the total budget is 57 units for September for this property on a large lot. Okay, so January, right? January, it's a different evapotranspiration rate. The indoor budget's the same. Everything else is the same, except the evapotranspiration rate has changed. It's gone from 6.42 to 2.17. It's not as hot in September. You have some rain coming in January. That has changed, right? So now the outdoor budget went from 49 to 16. If you add that to the status quo indoor budget of 9 units, that means the total budget for this property, same property, but it's January now, is 26 units. You can do that on a small lot too, right? And when I said small lot, I just wanted you to see the example. The small lot on the right, there's 6,000 square feet lot. 4,000 of that is hardscape, so they're only irrigating 2,000 square feet. You can see that their outdoor budget is dramatically different from the large lot. Then you're billed according to, did you make these numbers? Herein lies, in my opinion, the problem. I don't know how a customer would be able to track this. Like customers have a whole nother life. They don't have a whole lot of time to say, oh, it's September. I mean, yeah. Should you get a weather-based irrigation controller? Yes. But all of this is predicated on all of that working really well. So this is my problem with water budgets. I love the fact that they're equitable. I love the fact that they're individualized, but I just don't think most customers, it's not a friendly budget like tiered rates. So you're always welcome to call me, or I hope this helped you, and let me know if you need any help. Thanks.